The purpose of this video and other videos that I keep posting on YouTube is to improve understanding of physics by the students. So generally, whenever I create a video in physics, I try to see the videos which are available on the same topic or similar topic and see if any improvement can be made in the explanation, which will improve conceptual understanding of the students. So this is one such video. I have already posted one video on constrained motion. This is the second one. And if you feel that this explanation is helping you to understand conceptually better the physics of the problem, then you please subscribe to my channel so that more subscribers will motivate me to continue this work. So I'll discuss the problem. So here the problem is there is a block on a wedge. The block is tied to a rope, and then the rope is fixed to the wall. Now the question is, if the block is accelerating with AA, what is the acceleration of the block? If the wedge is accelerating uh, with acceleration AA, what is the acceleration of the block? So this is the block and this is the wedge. Maybe better we call it wedge, AW, so that there is no confusion. AW and AB, what is the relation between the acceleration of the wedge and the block? So let me call it wedge. So here we can see when the wedge moves, assume a situation where the block is fixed to the wedge. If this is fixed to the wedge, then what would happen is after some time, when the wedge moves by a distance, so we need this much, so here which moves by a distance x, then the block also would move a distance x if the block is fixed, or to be fixed on the plane of the wedge. But here we have situation, this is not fixed, but it is tied to the rope. So because now this length, when it moves, the wedge moves by a length x, this much of rope comes over the inclined rope, so that the block will slide down by x, because there is extra length of the rope which is available, so it comes here. So that means if the position of the block was here, so with respect to the earth, it would have come to this place. So this is the movement that has happened. With respect to the block, it has moved like this, but with respect to the ground, it has moved this and this. So we will have, this is a displacement. If this is x and x triangle, and this angle is theta, let me just enlarge it a little bit. Yes, I think this makes it little more, it has become too much. Oh, yeah, maybe this is a bit better. So we have the, this is x, this is x, and this is x. So this is the displacement. So this is the triangle. So this is the displacement. So we can write s square is equal to x square plus x square minus 2x square cos theta. This from basic trigonometry we get this. So we find s square is equal to 2x square minus 2x square cos theta. So this gives us 2x square 1 minus cos theta. So this gives us, when we take the displacement, it is x under root 1 minus cos theta. So we know the, if s is the displacement, ds by dt is the block acceleration, and dx by dt is the acceleration of the wedge. So we can say that the wedge and the block acceleration are related by a of block is equal to a of wedge, or root 2 1 minus cos theta. And in one of the examples I saw that they use theta is equal to 45, then you get AB is equal to AW, you get 2 under root minus, this becomes root 2. So this is an answer I hope has is derived in a easily understandable way. Yeah. So I think I can continue here itself to discuss one more problem. This is also is an interesting problem, and you will find the, so this is a case of two rings which are on this. Let me change the color. There is one ring here and another ring here, and there is a rope which passes through this ring, and it is tied to this. So this here it can slide. This also can slide. Now this is angle alpha. Now the problem is, if this is going with velocity v, then what is the velocity with which this will go up? That is the question. So here we can see that I will redraw this diagram a bit. This is a rope. This rope is tied to this, and this is my alpha. Here we can see that what we are interested in is, if I join this and this, so this is the vector r. Vector r is equal to vector r1 plus vector r2. Now here what we are interested in is the dr by dt. We can write it as maybe we can write it as r dot x I plus r dot y j. That is, I take this to be x and this to be j. That is, I take my xy axis like that. Then this is a vector, and we can see the projection of this vector on x is not changing. So this is always 0. So what is not 0 is r dot y. So our job is to find out what is r dot y, what is the speed of this. So we can write, or this, suppose if I take this as b and this as ring a ring b. Now what we are talking about is the position of the ring b. So the ring b position, the y component, we can see is this, which let us say is y. That is, we can say y of a. So this a is actually always on the y-axis. There is no x for the, this is ya. Then plus we can see this. Suppose if the length of the rope is L, this is L minus y, and we can see this is alpha, and this component is L minus y cos alpha. So the RBY, the ring y component, is the y component of A plus this much, L minus y A into cos alpha. This is the y coordinate of the ring B. So what we do is we try to differentiate. This is the velocity that we are looking for. That is ry dot rby by dt. This is rby dot ry. Okay, we can put b. This is ring B. The y component of the velocity of the ring B is equal to the velocity of the ring A, which is given to be v, plus here we are having L minus YA. So we have, this gives us minus V, YA by dt is V. Then we have cos alpha. Then we have cos alpha becomes minus sin alpha. This we have L minus YA into sin alpha d alpha by dt. This we can write as V of B, the velocity of B, is equal to velocity of A. This is A plus, sorry, this we can take it as minus. Then what we get is VA cos alpha plus L minus YA sin alpha by d alpha by dt. Now we can see that the width, if suppose if you take W, then we know sin alpha, this is alpha, is equal to W by L minus Y by A, L minus Y. This is sin alpha. So this we can write as L minus YA is equal into sin alpha is equal to W. So what we try to do is we try to differentiate both sides. So what we get is the first term gives us minus dya by dt into sin alpha. That is the differentiation of this into this. Then we will have plus L minus YA. This is cos alpha d alpha by dt. Differentiation of this is equal to 0. So this goes, this L minus YA into d alpha dt. That is what we need here actually. We have to plug into this. So L minus YA into d alpha dt is equal to, this we know is VA, velocity of the ring VA. Then we have, this is sin alpha by cos alpha. This gives us VA tan alpha. Now we will plug in this into that expression, into this. Suppose if this is A, we use this in that expression. What do we get is VB is equal to VA minus, we have VA cos alpha plus, this is nothing but VA tan alpha. So VA tan alpha into sin alpha. So now this becomes very straightforward. You can see this. So VB is equal to VA minus, this becomes, you get VA, then we have, the whole thing becomes this cos alpha, this is cos alpha. So this is cos square plus sin square becomes 1, then we will have cos alpha. This will go, we have VA into cos alpha minus 1 by cos alpha. So we can write this cos alpha, we can write this. Sorry, let me.